Some links on the front of your packet as well. We're going to talk about, believe it or not, take a look at that word up there. It's pronounced arithmetic. Gosh, I can't stand that. You know, one of the things I don't like about math is when they use the old English just to try to mess with people's heads. So I'm going to say it one more time. That's called an arithmetic sequence. That's because if you go to Khan Academy or anything like that, I want you to know that they're talking about the same thing that you're looking for. But I want you to think arithmetic. That's what I want you to think. And that's how we pronounce it now anyway. Because if you think arithmetic, arithmetic is the most basic math that you first learned. It's the teacher brings around the M&Ms and says, oh, you have 2 M&Ms on your desk. I'm going to put 3 more on there. How much do you have now? 7. 7. Oh, to break a couple in half. Put them on there. All right, so you had 5 M&Ms. And that was basic math. That was 2 plus 3 will give you 5. I mean, that's basic math. So it is addition. Now, we're not basic math anymore. So what we know is this. We can also add negatives. So if we see, and again, it's what we're looking for with patterns. If we see the numbers are going up, we want to know by how much are they going up, and we try adding. If we see the numbers are going down, we should also try thinking not just subtraction, but maybe adding a negative, because that's what arithmetic sequences do. But again, think arithmetic. So arithmetic sequence, a sequence of numbers where the difference between consecutive terms. You know, I just wrote up there a second ago that this is addition, and now they're saying difference. And difference means subtraction. Well, yeah, if you want to know what they're adding, just subtract to find it. That's what they're saying. It makes perfect sense. If we can't see what they're adding because maybe it's a decimal or a fraction that we don't like working with, we could always just subtract, and then we'll be able to figure out what it was they added. So that difference has to stay constant. When we were going through that first section, I always try to see, are they adding the same thing every time? Because those are easy rules to write when it's always the same. Well, it turns out we have formulas for those. If we look at a sequence of numbers and we see, hey, they're always adding the same thing, bam, we're going to use arithmetic. Which brings me to the front cover of your packet. Everybody go to the front cover of your packet, and I want you to go ahead, it says definition there for arithmetic sequence. Go ahead and write down that arithmetic sequence definition. It says a sequence of numbers where the difference between consecutive terms is constant. And the key word, constant. So let's fill in that box. And as I said, most of the time, we'll know right away when we look at them. We'll say, oh, look, they're adding 7 each time. Or, oh, look, they're adding a negative 5. But sometimes it might be hard to figure it out. If it's 9.3 and 17.2, then you just use a calculator and you subtract to figure out what they added. So an arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant. The difference between consecutive terms is constant. It stays the same, no matter what. Otherwise, it's not an arithmetic sequence. Now, that difference that stays the same, after everybody has that done, I'll uncover this one so you can go back to the inside of the packet. That's called the common difference. Make sure you get that definition for arithmetic sequences on there. Because that front page is what I'm going to have you use just when you have your homework. You know, you're working through your homework and you're like, well, what do I do for this? Bam, you slap your packet down and you say, oh, these have to have a common difference. Oh, those are the ones I need, and you use those formulas. Or you notice, hey, they're multiplying by the same thing every time. That's called a geometric sequence. It'll have formulas for that. So it's kind of a nice formula sheet, and you'll get used to it, and then by the end of the chapter, I'll give you a formula sheet, and you'll know exactly which ones are for which. So we've got a sequence of numbers where the difference between consecutive terms is constant, called the common difference. Now, grab a highlighter. Going to be one in your bag, if nowhere else. Grab a highlighter. Because here's what we're going to do. We're going to go through these formulas, and we are going to highlight what we are responsible for, what we are supposed to put into the formula. The rest of the stuff stays in the formula. It's kind of like when you write an equation for a line, there's an x there and there's a y there, but we put the slope in and we put the y-intercept in there. So with these, we want to know what are we supposed to do and what are they going to give us. So first, they're saying, let's just say we make up a sequence, 3, 5, 7, 9, etc. The first number, we would label a sub 1. We did that on Friday, where we just say, hey, that's the first term. And then if somebody says, well, to get to my next number, I need to add 2. Well, that's what this is saying. Go ahead and take your 3 and add 2. That would get us a 5. But now they're saying, go back to the beginning, and I want you to add 2 twice. Well, most of us would say, well, that's just adding 4. So 3 plus 4 is 7. So it's a way to describe what's going on without going in order, so that you'd be able to figure out what's the 10th one, what's the 12th one, without having to do all the others. And that brings us to these two really, really nice formulas. And what we're going to work with this year is always going to start with a sub 1. So we'll put a little 1 down there. The reason I say that is because if you study sequences and series in college, we don't always start with 1. Sometimes we start with 0. It depends on what makes the formula easiest to work with. And over here, that'll be an a sub 1 for everybody in 10. That's what we'll do. Now, here's what we're going to highlight. We are responsible for finding that number, which is the first term. And we are responsible for figuring out what b is. What is that common difference? What are they adding every time? These are always part of the formula. A sub n equals a sub n minus 1. That's what makes it recursive, the fact that they use that previous term to find something. And then this one over here, it's the same thing. We are going to need to find a sub 1 and d. That's going to be our job. A sub 1 and d. We're going to put those numbers in, and we're going to simplify them, and we will have a formula. Now, I talked about this on Friday. Explicit, that's the way to go. I'm going to put a happy face there. That's the one we want. If we can get an explicit formula, we want it, because that's the one that, if you want the 200th term, you just put a 200 into it, and bam, you get yourself your number. But they're going to ask us to also do the recursive ones, just to make sure we have a backup plan to find them if we need to. Now, these need to go on the front of your packet as well. So plop that puppy back down. I get those formulas in the slots for arithmetic sequence. One is the recursive, the one on the left is the recursive, and the one on the right is the explicit. I'm going to go ahead and erase my green boxes because I don't want you to miss like the positive, the plus here. But you should put those a sub 1s on. And again, this is so when we get a little deeper in the chapter and they give you review problems and you're thinking, ooh, I need a formula for that one. You'll be able to flip back and find it. Notice all the pluses in this. You know, pluses because it's addition. We're adding the same thing every time. Adding that constant. So recursive, a sub 1 equals a sub 1. And then a sub n equals a sub n minus 1 plus d. Now, why do they put the n is greater than 1? Because, like I said, with you guys, we're always going to start with the first term. We're not going to use a 0 term. We're not going to use a -5 term, which makes no sense. You know, we're always going to start at 1. And then explicit, that's our favorite, because this is going to allow us to find any term we want. A sub n equals a sub 1 plus n minus 1 times d. Now, you might want to go back and highlight a sub 1 and d on the front cover, too, so you remember. Hey, all I'm supposed to put in is a sub 1 and d. A sub 1 and d. The rest of it I just simplify. Make it look pretty. That's what we do. Everybody okay? Need more time to write down any formulas or anything? Oh, a couple people still right. Don't want to make you frantic. Got plenty of time. What do we need to write these formulas? What are the two things? A little louder. What do we need to put in the formulas? A sub 1 and D, the first term and the common difference. All right. Well, the first thing we're going to need to know is, do we know one when we see it? They're just asking us here, are these arithmetic sequences or not? Are they adding the same number every time or not? Look at A. Are they adding the same number every time? This is arithmetic. Now let's go a step further because they do this in your homework. They want you to tell them what are they adding every time. What are they adding? 3. So once you recognize that it's an arithmetic sequence, you figure out what are they adding. Look at B. It's 1, 4, 9, 16, 25. Is that arithmetic? No, they're not adding the same thing every time. Do you recognize those numbers from Friday? The perfect squares, exactly. Those are the perfect squares. So it's not that there's not a pattern, it's just that it's not added. You know, there's a pattern there, but it's not addition, and arithmetic is for addition. Got it. Number 1A says, is the sequence an arithmetic sequence? And we have 2, 4, 8, and 16. Is that arithmetic? Nope. Nope. They add 2, then they add 4, then they add 8. Is that a pattern? Yes. Is it arithmetic? No. It's not arithmetic. Thank you, Brent. So take a look at B. 1, 5, 9, 13, 17. Is that arithmetic? Yes? What are they adding each time? 4. So we need to know them when we see them. We want to know, hey, this is arithmetic, so we can use the rules for arithmetic sequences, which we are getting to right now. It says, what is the 100th term of an arithmetic sequence that begins with 6 and 11? They flat out told us this is arithmetic. And every time I see a problem that says it's arithmetic, I'm writing down this formula. Because chances are pretty good that if it's arithmetic, I'm going to need it. Now, you'll notice that they had the 100th term. I don't know about you, but I don't want to find the 3rd, then the 4th, then the 5th, then the 6th, etc. I'd like a formula that would give me that 100th term. And that means I have a couple of things I have to find. This and this, that's what we highlighted before. And then I'll just simplify it, and then it'll be an explicit formula that we can use to find them. So let's see. What is the first term in this sequence? Yeah, some people will look up there and think it's a trick question. Honestly, do we just look up there and find the first one? Yeah, that's what you do. It's a 6. And what are they going to be adding each time? 5. Now, if you're thinking, how do we know it's going to stay 5? Because they said it's an arithmetic sequence. It has to stay constant. Now, here's where it gets a little weird. Because we have to distribute from the right-hand side. We don't like that. But we're going to distribute this 5 through these parentheses and see what we get. So a sub n equals 6 plus 5n minus 5. And then we go ahead and combine like terms. A sub n equals 5n plus 1. So now, whatever term they want us to find, all we have to do is put it in for n, and we'll be done. And they wanted the 100th term. So a sub 100 equals 5 times 100 plus 1. So the 100th term is 501. Again, that's an explicit formula. That is absolutely what we want. That's what we prefer if we can get it. Sometimes we can't. Sometimes you have to use it. But that wasn't too bad. Put in a couple of numbers, simplify. Ooh. You know the book. Here's what happens. They give us everything we need, perfect case scenario, and then they start taking things away. So I look at this one and it says, what are the second and third terms of the arithmetic sequence 100 blank blank 82? They just took away the common difference. Now some of you that are really good at patterns, you've already figured out what the two numbers are in there. That won't get you credit on the test. You have to show it with formulas. So we look at this and we say, all right, I need to know what I have. Let's take inventory of what we have. I know the first term is 100, and I know the fourth term is 82. That's what I know. I also know that it's arithmetic. which means I'm supposed to be able to use this formula. So I start thinking, I have a lot of variables in here. And if I want to find D, I have to find a number to put in for the other three. If I can do that, then I can find D. So, what do I know? I know the first term is 100. That's what I know. And I know the fourth term is 82. So I know that if I put a 4 in for n, the answer is 82. I absolutely know that. And now I'll be able to find D because I had 4 variables and I knew 3 of them. Of course, we're going to follow the order of operations and say 4 minus 1 is 3. And now this is just a 2-step algebra equation. You subtract 100 from both sides. What do you get if you take 82 minus 100? Minus 18. Divide it by 3. And D is negative 6. Now, we can go ahead and write the rule. We know what D is, and we know what A sub 1 is. So A sub n equals 100 plus n minus 1 times negative 6. We'll distribute from the right and combine like terms. And now we can find whatever they ask us to find. But let me explain something here. There's actually 2 ways to do this one. We just found that D is negative 6. That means they're adding negative 6 each time. So we could actually go up here and kind of cheat and say 100 plus a negative 6, that'd be 94. So the second one is 94. And if it's 94 and we're supposed to add a negative 6, well, 94 plus negative 6 would be 88. So the third term would be 88. And we can double check it by saying, okay, 88 plus a negative 6, that'd be 82. Oh, look, 82. Or you can use the formula. If you want to use the formula, you can put a 2 in here and get 94. If you want to put the 3 in there, get 88. Both ways. They're both available. Just because we know the formula. That's what we want. So there are 2 very nice problems down here for you. And I will get you a candy partner, and you can start working your way through 2A. Stop when you're done with 2A so that we can get you to check in with somebody and make sure you're getting the right things. And then together you can work on the rest of this. This will actually fix my odd one. All right, wherever you're at, let's stop, find that candy partner, and show them what you've been doing, see what they've been doing.
Well, that's the same one as hers. What'd you end up with? Where are you guys going? Where are you guys going? Yeah. You guys on the hotel? Sorry. Sweet.
This is n. And we don't put anything in for n. We put the first term in for a sub 1. And then we put what they're adding each time in b. Yep. Plus 1. Exactly. No, just multiplying. No, let's replace this, because this is for the first term. And the first term is a 3. 3 plus, distribute it this way.
So we're over. This one, yeah, this is the same thing. Right.
All right, the first one looks pretty good. Most people are getting 93. Once you've double checked your math on that one, if you haven't already gone on to B, go ahead and do it. It's just like the B that I did.
You're okay. What'd you get? What'd you say was? 50. Take 80 minus 1.5. 54.5. Divide that by 30. It's old man. Yeah,
Work
45.
term is 1.5.
Alright, then you divide by 5.
Yep, keep going down.
You're not getting the term.
Can't afford that.
Minus 1. 35.
Right, if you wanna use the formula, 15 to rich.
Thank you, Greg.
That's 4 minus.
Yeah.
And trying to help you. Then fall down by 2 times. Make that Read the version of B again. Right, you take it out.
Alright, lots of people to that point where it's, okay, what do I do with this? Well, if you want the second term, you've got your formula written, you could just put a 2 in there and get your answer. So 15 times 2 is 30, 30 plus 65 is 95. Or, you could say, the common difference is what they're adding each time. And that means they're adding 15. So 80 plus 15 would be 95, which is exactly the same thing that we got from our formula here. And then if we take 95 plus 15, we're going to get 110. So you either can use the formula, or you can use the fact that you know the common difference is what they're adding every time. So, because it's a sleepy kind of day where people didn't get enough sleep, that's all I'm going to cover today. So you can thank your partner.
Thank you.
And give that a try.